particle mass 10 kilograms, describing a circle on a smooth horizontal table. So that is my, that all day says use your parallelogram. And your, well, okay. And it's here to here. I'm going to use the pink thing again. Okay. This is a height of 0.4. 0.5. Going to use Pythagoras' theorem to find the length of the radius, which is the red line, and we all agree it's 0.3, do we? Okay. If this is angle x, yeah, would you all agree that cos x is 3 over 5 and sine x is 4 over 5? Okay. Then the only thing causing the it's in contact with a table, is it? So that would mean, get rid of that for a minute. Means your reaction force of R, which is 20 newtons, 10 kilograms, which is 10 G, which is 10 G is 98 newtons. Would you agree with that? Okay. 98 newtons going downwards. Okay. Now we all agree it's tension, don't we? That's keeping it in the game. Now, all right, guys. Everybody got T, yeah? Now, this is 4 over 5T is going upwards, and the 3 over 5T back in towards the center of the circle. Now, what goes up has to equal what goes down, yeah? So, I think the 98 newtons going downwards has to be balanced by the 20 going up plus the 4 over 5T. That implies that the 4 over 5T is worth 78. So we're going to get 78 and we're going to multiply it by 5 and divide by 4 to find the T value. So what's the T value? What? 97.5 newtons. Is that right? Do you want to double check that? All good? Okay. Next thing. We're going to do, we found the tension, we found the radius. Now we need to find the constant angular velocity. So that means FC, which is 3 over 5 times tension. How do I know it's 3 over 5T? It's in this direction here, isn't it? That's the only horizontal component aiming towards the center of the circle. And we replace T with 97.5. What you say? Because I broke it up into its components. See, the tension was going diagonal. And when we did forces up versus forces down, we used the 4 over 5T, which is going directly up for forces up versus forces down. That leaves the horizontal component. And remember, it's a horizontal circle. So that's the force that's aiming along the circle towards the middle. It's always done that way in no, that's the radius. The radius is 0.3. It's cos, it's T cos x. The component of tension along the, exactly, that's what we've been doing. Last two questions, yeah. Okay, what's M? M, anybody? 10. Radius? 10 times 0.3 omega squared. All right, so 10 times 0.3 is quite simply 3, isn't it? Cancels that 3, doesn't it? So what's 97.5 divided by 5? 19.5. Square root that. 4.42. Everybody happy with 4.42, Rad? Now, in the next question, what's happening? Do they make me faster or slower? What's root 24.5, Rad? Put it in the calculator. 4.94. They're making me faster. And when you get faster, you start to lift. See? Slow. Fast. See the way it starts to lift? So what's going to happen is there will come a point where you start to lift, okay? And this point, now I'm going to get rid of this last part. What happens when I spin something faster? The tension will go up. Do you see your 97.5? Everybody see that? That's no longer the tension because we're spinning faster than we used to. We're spinning so fast that the reaction force R is no longer 20 because it lifts off the ground. And because it lifts off the ground, what happens to it? It turns to 0. Multiply 5 by 98 and divide your answer by 4. And that will give you your new T value. Was it? No, it has to be bigger than 98. 100 and? Yeah. Is that okay? Because it's on the point of taking off. When you're on the point of taking off, you're no longer in contact with the table. Tiny gap. And then the R value ceases to exist. Or it's so small, it's considered negligible. Do you know what I'm saying? It's touching it by such a small degree, it practically doesn't exist. Is that alright? And then what we do next is we take our new T value back into the 3 over 5T equation. Remember we said that's what points towards the center of the circle? And that has to equal mr omega squared. We're looking for a new omega value. So what we're going to do is put m as 10, yeah? The radius is still? What? Is it 1.2? 0.3. And once again, the 3 and the 3 cancels, don't they? So it's going to be 122.5 divided by 5. I'm pretty sure that's 24.5, isn't it? And then equals omega squared, and then omega equals the square root of that. And we don't even have to do that for what reason? To show that question, isn't it? Okay, happy days.